Alright, we've learned many different ways to find sides and angles of a triangle. We've talked about Pythagorean theorem, we've talked about just triangle sum theorem, where we know all the angles add up to 180. We've talked about a lot. Okay, we don't always have these shortcuts that we can use. Instead, we have different kinds of shortcuts that we're going to use, and those are called trigonometric ratios. So your goal today is to be able to find missing sides and angles using trigonometric ratios. Okay, so this is in a case when we don't have a 45-45-90 or a 30-60-90. Maybe we have a 31-60-89 right triangle, or that wouldn't be a right triangle, or 31, we could do 31-59-90 right triangle, something like that, where we don't have these quick, easy ways we can do them. So when we have that, we end up using trigonometry. Okay, and that's just a comparison of side ratios to an angle, and I'll show you what that means as we go on. For some terminology, side A would be considered opposite to angle A, because side A is here, and it is opposite angle A. We would also consider side A to be adjacent to angle B, because it's right next to angle B. We would consider side B, if we look at side B, what is that to angle A? Well, it's right next to angle A, so we would call that adjacent to. We would call side B also what to angle B? Well, it's straight across, so we would say that's opposite. Okay, so we have a combination of opposites and adjacents. And lastly, C, or the hypotenuse, is always listed as the oops, that's not how you spell hypotenuse. Is always listed as the hypotenuse. It can never be an adjacent side, it can never be an opposite side, and we'll get into that as we continue. So using that information, we have these fancy buttons on our calculator, and they're not pronounced sin, cos, and tan. They're actually for sine, cosine, and tangent. Okay, and what they are is just ratios or comparisons of two sides. The sine button happens to be a comparison of opposite sides over hypotenuse. Hypotenuse. The cosine is a comparison between adjacent sides and the hypotenuse. And the tangent is a comparison of the opposite over the adjacent. So we have all our possibilities in there. Okay. Now using that, we're going to set up different ratios. Okay. Now it might not be that easy for you guys to remember sine, cosine, tangent, what ratio is what. You may have heard a brother or sister talk about an easy way to remember that, and we refer to it as SOHCAHTOA. The sine is opposite over adjacent. They're opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. So we have SOHCAHTOA. You will write that down a lot on papers, quizzes, tests. You will use that. But again, you always are looking at that first letter as to what function you're using, and then the ratio decides is it opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So using that, we're just going to get in the habit of practicing some of this. So express each trig ratio as a fraction and a decimal. Okay, so if we look at this, the sine of A, so we're focused on just angle A right now. Angles are always the capital letters. We would say that sine is opposite over hypotenuse. So opposite of angle A would be 12 over its hypotenuse. Well, we don't know that. So what we could do to figure out the hypotenuse is say, okay, this is a right triangle. I know two sides. Let's go ahead and figure out what this is. So it's going to be 25 plus 144. And you guys have probably seen this one enough to know that's a triple. So this ends up being 13. So the cosine again is the adjacent, so it's next to 5, and then 13 over the hypotenuse. Notice how if you're at angle A, you might be thinking you have two adjacent sides, but we said before up here that side C, or the hypotenuse is always just called the hypotenuse. It's never opposite, it's never adjacent. So if cosine is 5 over 13, the tangent of A, if we look at A, that would be opposite, which is 12, over adjacent, which is 5. Okay. Oops, I didn't write the first one. Sine A is opposite over hypotenuse, which is 13. Sorry about that. Okay, so that's just writing those as a fraction. We go back through and say, okay, 12 divided by 13 is approximately 0.92. 5 divided by 13 is approximately 0.38. Notice how I'm saying approximately. 12 divided by 5 is 2.4. Okay. So again, these are just ratios. So for every 12 units the one side gets, the other side gets 13. Okay, so it's 12/13ths of the other side. That's how you could look at it, like a percentage almost. Let's try it for side C now, or angle C now. So sine of C, that's, if we look up, it's opposite over hypotenuse, which is 13. So it's 5 over 13. The cosine of C would be adjacent, 12, over hypotenuse, which is 13. Tangent would be 5 over 12. Now, the nice part about this, you may notice some of these are already done for you. 5 over 13, we already said was 0.38. It's just a different comparison. 12 over 13 is 0.92. We need to do 5 over 12 because we don't have it. So 5 divided by 12 is about 0.42. We round up. Okay, so again, those are just ratios of the two sides. Okay, so if we look at another little example before we get into actually finding some of these, and then I think it might start clicking with you guys. If the sine of A is 3/5, so we know we're looking at a triangle. So the sine of A, we'll call this A, this B, that C. I will tell you right now, we will never use the right angle as a starting point. So it would always be like A or C, those corners, not the right angle. We'll never use that as part of these trigonometric functions, never ever. So sine A is opposite over hypotenuse, if you look back up. So if the sine of A is 3/5, then we're going to say, okay, opposite is 3 and hypotenuse is 5. What is the tangent of A? And we want to be able to write a ratio. Well, tangent of A is going to be opposite, which is 3 over, we don't know what the adjacent is, so we have to find it. Again, a little Pythagorean theorem here, you would do a squared plus b squared equals c squared, or you may know by now that this is a 3, 4, 5 right triangle, and there would be your tangent. So again, just using pieces to find some other information. Let's look at some of this where we can actually go ahead and apply. For the following problems, solve for the given variables. Round to the nearest hundredth. And again, if you're still a little bit lost, stay with me, and I think as we start plugging in some numbers, we'll be able to put this all together. So notice it's not 30, 60, 90. We don't have two sides, so we can't use Pythagorean theorem, so we have to use trig. First thing you need to do on your calculator, whether it's this kind of calculator or something similar, go to mode. Where it says radian and degrees, we won't use radian at all this year. We need to put that in degrees. Okay, so make sure you hit enter on degree and leave it on there. Make sure that's the one that's flashing. Hit second mode to get out. Okay, we have to be in degrees because we don't talk about radians in here. Next year you will, not this year. Okay, so we are always in degrees. If you get funky answers, you got to check your mode, make sure it's in degrees. So that's the first thing. We'll come back to that and I'll show you how to do everything on your calculator. So if we want to find x, y, two separate setups. So our focus is always on the angle. We know this is 13 degrees. If we wanted to, we could say, okay, the top angle then is 180 minus 90 minus 13, and this is 77 degrees. We could use that angle if we want to. Okay, so what we're going to do is set up two different ones. So if I have 13 degrees here, I want to compare a side I don't know with a side I know. What I mean by that is if we want to find x, so if we're looking at 13, okay, we want to find x. X is across from it. We need to compare it to not y because that won't help us, but we need to compare it to 90. So we're taking opposite, which is x, over 90, which is our hypotenuse. So what is opposite over hypotenuse? If you look, that would be, and I'll put this over here, so toa, we have opposite over hypotenuse is the sine of 13 equals 90, or x over 90. Okay? And what this is going to allow us to do is to figure out, based on that ratio, what that side x would be. Okay, so to do this, a couple different things you could do. You could make this over 1 and cross multiply. That's probably what I would do. Okay? Or you're really just multiplying both sides. So we'll go ahead and cross multiply and we'll say x equals 90 times the sine of 30. That's exactly what we'll punch into the calculator. So let's go ahead and I'll show you on here. So 90 sine 30. So what's going to look like is you'll say 90 times the sine of 30, just like that. And it's going to tell you exactly what that side is based on what you've got. So 90 sine 30 is, oops, not sine 30. That's why it came out so nicely. Should be sine 13. Just copied it down wrong. So let's try that again. 90 sine 13, and we get 20.25. Okay, so x is 20.25. There's one answer. Let's do another setup. So we have the same kind of thing, and let's look at 13 again. We need to compare it to two sides, and if we wanted, we know that this side is 20.25. I wouldn't use that side because it could get a little bit messy with what you have. So let's go ahead and look at 13 and say, okay, 13, I need to find y, and I know I have that 90 there on the hypotenuse. So I know I have to use hypotenuse, which leaves it to sine or cosine. So which one do we need? Well, y is the adjacent side, so it's going to have to be adjacent and hypotenuse, which is cosine of y. Keep doing that. Cosine of 13, sorry, is equal to the adjacent y over 90. Again, if you want to put that over 1, cross multiply, y equals 90 times the cosine of 13. Punch that in. So 90 cosine 13 comes out to be about 81.67. Again, if you want to punch that in your calculator, this is what it's going to look like. 90 cosine 13. And you might be thinking it should be 20.24, whatever we got before, but that's not necessarily the case because, and I just got something different than what was on my calculator. What the heck? Let's try that again. 90 cosine 13. What did I punch in up here wrong? Oh, I was in degrees on my calculator. That's not on screen, so that's what we should have. 87.69 here. So that's my fault. I was using my one that I didn't adjust, and that's why I knew it was wrong. 87.69. But again, you might be thinking you should have got the same thing as 90 sine 13, but it's a different comparison. Okay. So that was a little choppy. Sorry about that for switching back and forth there. So now I'm in degrees and everything. Let's look at the second one. So we have number 4. We have 15 degrees here, and we are going to focus on that. Again, if we want to, we could figure out that this over here is 180 minus 15 minus 90, which is going to end up being 75 degrees. So we can use that one. We can use either angle to start. Again, we never use the right angle. So, for example, let's work with 15. Okay, we know that we have to include either x and 10 or 10 and y. We can't do x and y in the same one. So let's go for x first. So x is adjacent to 15, and 10 is opposite 15. So I have adjacent and opposite. That should tell you that you need to use tangent. So we're going to use the tangent of 15 degrees is equal to the opposite over the adjacent. Again, cross multiply. So we have x times the tangent of 15 equals 10. Okay. To get x by itself, we just divide by the tangent of 15. Okay, just like it's any other number. So x is equal to, and again, we're going to punch that in exactly how we see it. So 10 divided by the tangent of 15, and we get 37.32. So 37.32 units is x. Do the same thing for y, and hopefully you're catching on by now. So to find y, again, we'll look at 15 as our starting point. We have, that is the y is no matter what the hypotenuse. We were given at the beginning that opposite. So which one has opposite and hypotenuse? Well, that would be your sine. So sine of 15 is equal to the opposite, which is 10, over the hypotenuse, which we're trying to find. Again, put it over 1, cross multiply. So we have y times the sine of 15 equals 10. Get y by itself by dividing both sides. So y is equal to, so 10 divided by sine of 15. 10 divided by sine 15. Oops. There we go. So we have 38.64. Okay. So again, it's setting it up as we go. Let's do one more together, and then we're going to do 6 and 7, or 6 and 8, I guess I made it tomorrow in class. Okay, so those are your couple answers so far. This takes practice. Calculator does it once you have it set up. So let's look at this and find out what information we already know. Well, if this is 21 degrees, it's a right angle. 90 minus 21 is going to give you 69 degrees there. Okay, we know that these are alternate interior angles. We should remember that. So we have everything down that we need. Again, you can pick if you want to start off at 69 or start off at 21 degrees. It doesn't matter which one you start with, as long as you're working with it appropriately. So let's look at 21 degrees, and I'm going to start there. I want to use 40. So again, if we need to write this out, SOHCAHTOA. I'm going to use 21. We know 40 is the hypotenuse, so we have to either use sine or cosine. And then I'm going to try and find x and y. So it depends on which one I'm trying to find. So let's look at and try and find x. So if we're starting at 21 degrees here, I know the opposite is x, because it goes across this triangle. So the opposite is x. And then I need to use the hypotenuse. So I'm using opposite hypotenuse, that's O and H. So we have this sine of 21 equals opposite over hypotenuse. Again, put it over 1, cross multiply, 40 sine of 21 equals x. Punch that in your calculator. I'm going to let you guys do it from here. I'm going to just do it on my one that I now have in degrees. So 40 sine of 21, x equals, or x is about 14.33. So there's x. Same idea we can use to find y. So start at 21. And y is the adjacent side to 21, and 40 is still the hypotenuse. So adjacent hypotenuse, A and H, we have to use cosine of 21 is equal to y over 40. Adjacent over hypotenuse, again, cross multiply. So we have 40 cosine 21 equals y. Again, now it's just all up to your calculator. As long as it's in degrees, you should be good to go. Y comes out to be approximately 37.34, and there are your two missing sides. So again, similar to what we've been doing before, but now it's more calculator. It's probably easier to you guys to use specialized once you get this part down, where we have sine, cosine, tangent, all that information there. Okay, there will be single triangles, there will be double triangles like this. Okay, so we will look at doing 6 and 8 tomorrow in class. We'll talk about those, and then if there are questions, make sure you guys have those ready for tomorrow. See ya.